Hello, and thank you for joining us. Today's webinar is Manual versus Automated Methanol Extractions, presented by Jeremiah Bradley, Applications Chemist at Teledyne Tekmar. We will not be taking live questions today, but please feel free to submit your questions using the question function throughout the webinar, and we will respond. One of our staff members will respond within 24 hours via email. Okay, Jeremiah, I'm going to turn it over to you.
Okay, thank you. Hello, everyone, and welcome to Tekmar University e-learning webinar series. As your host, today's webinar topic will be on a manual versus automated methanol extractions. For those who are new here, I'd like to start with a brief background on Teledyne Tekmar and give you a quick overview on Persian trap. Teledyne Tekmar is a leader in design and manufacturing of analytical instrumentation for laboratories, providing productivity enhancement instrumentation and solutions to several industries. Our world-renowned product line include volatile organic compound systems for gas chromatography sample introductions, including Persian trap sample concentration and static dynamic headspace analysis. Additionally, Teledyne Tekmar manufactures a line of total organic carbons and total nitrogen analyzers, which provide unparalleled accuracy, precision, throughput, and robustness for water samples. The contents of this webinar will also cover a few of the Thomas XYZ key features, the instrument that was used for this demonstration, and the methanol extraction methods, both manual and automated, comparing their similarities and differences. I will also mention some tips for the methods that were used. So, what is Persian trap? It begins with a measured amount of sample being placed in a small valve or vessel. Then the sample is purged with an inert gas, causing the VOC to be swept out of the sample and carried to an analytical trap. Upon desorb, the trap is heated and the VOCs are swept onto the GC by backflushing the trap with an inert gas. The purging gas that was used for this demonstration was nitrogen. As you might have guessed, for this high concentration methanol extraction analysis, we used the Thomas XYZ. The Teledyne Tekmar Thomas XYZ is a Persian trap concentrator with a built-in multi-matrix autosampler. It is capable of running water, low-level soil, and methanol extraction samples. It has 84 positions for 40 milliliter VOA valves and offers an optional chiller tray for temperature-sensitive samples. The Thomas XYZ also features a patented dual-stage water heater and methanol rinsing capabilities, which helps with reducing carryover and promoting clean transitions between samples. This is very helpful, especially when working with highly concentrated samples that require methanol extraction. It is the first of its kind with automated methanol extractions, which is very helpful for US EPA 5035 users, as it will save you time and effort when preparing extraction samples. The mass flow controller is optimized for helium and nitrogen, meaning that either gas can be used reliably and accurately for Persian trap analysis. Additionally, the mass flow controller makes it easier to keep track of pressure and locate any leaks for proper maintenance. Lastly, the Thomas XYZ has a moisture control system to help reduce the amount of water that reaches your trap, extending the life of the GC column. When it comes to vial handling, the Thomas XYZ has a patented 3-stage needle, which allows for one of the sample stations to use for both liquid addition and removal from valve and in-valve purge for the soil mold. This means the water and standards can be directly added to the valve for an in-valve purge. The elevator features a valve heater that allows the samples to be heated, improving purge recovery. The trap cooling system uses air from outside of the Thomas XYZ chassis to cool the trap, allowing for a faster cool down time. And as mentioned previously, the chiller tray option is also available with temperatures as low as 4 degrees Celsius. Sample gas handling. The Thomas XYZ mass flow controller is optimized to use helium or nitrogen as the purge gas with input pressures between 65 to 100 psi. To avoid any cool points, the entire path is heated to temperatures set up to 250 degrees Celsius. Because safety is always important, the trap interlock switch turns off the trap heating power if the door is open to prevent any accidental injuries. The Thomas XYZ also uses a heated 6-port valve with controllable temperatures up to 250 degrees Celsius. The moisture control system reduces water vapor transfer to the GC by 50%, and the mass flow controller enables automatic leak checking, which, as I mentioned before, is a lifesaver when it comes to trying to find a leak. Depending on the mode of operation, it is capable of flow rates between 5 and 500 milliliters per minute. Liquid handling. The Atomic XYZ comes with a standard 25 milliliter syringe that allows for sample volumes in 1 milliliter increment and dilution capabilities up to 1 to 100. It also features 3 15 milliliter standard dosing valves for internal standards, surrogates, and can administer matrix spikes in 1, 2, 5, 10, and 20 microliter aliquots with no waste. They're also UV protected and sealed under pressure for standard concentration integrity. It also has a multi-port valve for sample, methanol, water, and drain controls. Sample pathway includes the standard number 9 U-shaped analytical trap for superior chromatography. Other materials include PEEK, inertium, silico steel, PTFE, and to your right is a general flow path of everything we discussed so far, where you can see the flow path of the water or methanol extraction during purge. Compared to its predecessors, the Thomas XYZ has a 22% faster trap cooldown time, 52% fewer plumbing connections, and up to 50% less water vapor transferred to the GC. More details of the Thomas XYZ can be found online using the e-link below. Methanol extraction. For those who are new to methanol extraction, or EPA method 5035, methanol extraction is a simple preparation technique for high concentration soil samples. Typically, a soil sample with a VOC concentration greater than 200 ppb is sampled in a fill and placed in a valve. Methanol is then added to that valve and sealed. Mixing or agitating the valve is required to help the VOC transition from the soil to the methanol for extraction. Depending on the concentration, an aliquot of the methanolic solution is added to DI water and analyzed under normal purging trap condition, or for the Thomas XYZ water mode. The Thomas XYZ capabilities of EPA 5035. So in EPA method 5035, there are 2 methods for extraction. For low levels of 5 to 200 ppb, methanol extraction is unnecessary, and the sample is purged directly in a 40 milliliter valve. Using a patented 3-stage needle, the volatile compounds are swept directly onto the trap. This technique is known as soil mode for the Thomas XYZ. For soil samples with a concentration higher than 200 ppb, methanol extraction is required. For this, the Atomic XY uses the automatic programmable dilution to extract 50 microliters or 100 microliters and dilute it in a 5 milliliter sample volume of DI water. This technique is known as methanol extraction mode for the Thomas XYZ. Here you can see the parameters of the water mode versus methanol extraction mode. Please note that the parameters highlighted in yellow were not used during this demonstration. You will likely notice a couple differences in the parameters when comparing the two. For example, unlike the water mode, the sample volume option is missing for the methanol extraction mode. This is because the methanol extraction sample is fixed for, for 1 to 100 or 1 to 50 dilution, where a 1 to 50 dilution removes 100 microliters of that methanolic extract and dilutes it in a 5 milliliter DI water, then purges it, whereas a 1 to 100 removes a 50 microliter of that methanolic extract and adds it to a 5 milliliter of DI water and then purges it. Since the sample concentration is also higher, the methanol rinse feature was utilized to ensure a clean transition and to reduce carryover. For anyone interested, here's the list of the GC and MSDS parameters that were used in this demonstration. A copy of the webinar is also available for your review if you would like to check the parameters of the section in greater detail. So, manual method. The manual method utilized the water mode method of the atomic XYZ with manual dilution. Begin by adding your 5 grams or 7 grams sand or soil sample to a 40 milliliter valve. Add 5 microliters of internal standard or surrogate standard using a gas-tight syringe. Then you can add your methanol, a total of 10 milliliter for 5 gram sample or 7 milliliter for a 7 gram sample. You will want to sonicate the valve for 20 minutes to get your analytes into the methanol. Using a 50 milliliter volumetric flask, fill almost to bottom with DI water, then add 2 milliliters of extract to the volumetric flask for 5 gram 10 milliliter samples or 1 milliliter extract for 7 gram 7 milliliter samples before you fill the volumetric flask to volume with DI water. Then invert 3 times and fill a 40 milliliter valve to volume, leaving no air bubbles. Make a 40 milliliter valve for each extract sample and place on an autosampler for water mode analysis. Automated method utilizes the methanol extraction mode. Begin by adding your 5 grams or 7 grams of sand or soil to a 40 milliliter valve along with a stir bar. Then place your autosampler then place on an autosampler for the methanol extraction for analysis. And it's really that simple, as the atomic XYZ will take care of the rest. If your sample valve has methanol already in it, make sure to take this into account when creating your parameters for the methanol extraction, as this will dilute it if you don't. Here's some other basic conversions and equations to remember when doing extraction. I know everyone has their own method for getting from A to C, but I find these to be the most helpful rule of thumbs to know. So you have for your conversions, your 1 ppm equals 1,000 microgram per kilogram. Your 1 microgram per kilogram equals 1 microgram per liter. Your 1 microliter equals 50 nanograms, and 5,000 nanograms per grams. A good equations to know is C1V1 equals C2V2, and your relative response factor equaling the analyte area times the internal standard concentration over the analyte concentration times the internal standard area. As seen in the previous slides, the two methods do share some similarities in terms of extraction, sample volume, and Persian trap analysis. The internal standard is delivered with consistency using the 15 milliliter standard valve vessel at 5 microliters. Your key difference would be effort and time. You spend a lot more time doing methanol extractions manually by adding the methanol, then the surrogate, then sonicating, then removing the aliquot and diluting it in water when you can simply put the sample in a valve and press go with the automated process. One thing I do want to note though, in methanol extraction mode, the standard vessel valve 3 is for high spike concentrated internal standards and surrogates. So if you use standard valve 3, it's going to add the surrogate directly to the valve, which will be diluted by methanol, 7 mils or 10 mils or however much you want to set it for, before it is sent to the sparger. In the methanol method, internal standard valve 3 is injected into an additional methanol that is added to the valve before it's extracted. So if you want to take advantage of this feature, you must add an additional methanol to the valve. It cannot be loaded onto the autosampler with the full amount of desired methanol already added. Here's a table with the results for the water/methanol extraction curve. Since they involve the same dynamic process, they use the same curve. In the chart, you'll also see the results for the manual extraction versus the automated extractions with the targeted concentration of 100 ppb. You will notice in the comparison that they have similar results as well, with consistent accuracy for all of their compounds of interest. Just as a good rule of practice, especially in terms of recovery, wet the sand or soil with methanol prior to analysis. Allowing the analyte time to transition into the methanol can help with recovery, especially with polar compounds that tend to absorb in sand or soil matrices sometimes. For low-level soil samples, sometimes using heating sparge vessel helps with analyte recovery as well. And with that, that will conclude this webinar. If there's any questions, feel free to email them as well. Thank you for attending this webinar. I hope you found it useful, and feel free to list any future topics that you would like to see down below. Until then, be safe and enjoy the rest of your day. Bye.